Hello, we're going to go through the solutions of the Unit 4.2 quiz number 1. This quiz was all on surface area, and we're starting with number 1, a hexagonal right prism. If you recall, for prisms they have two bases and then the lateral area. The easiest way to find the lateral area was just to take the perimeter times the height, because that takes care of all those rectangles with their base times their height. So in this guy we have a base that is a hexagon. So we have to remember from last unit when we found the area of a hexagon, we broke it up into 6 of these triangles. So each of these triangles, if you recall, is equilaterals, 60, 60, 60, but its base is 6. But to find its height, which we dropped in altitude here, that cut our 60, 60, 60 into 30, 60, 90. So this short leg is 3, and if you recall, the height then becomes 3 root 3. So our triangles are 6 are their base times 3 root 3 all over 2. We're multiplying by 6 because it's a hexagon, and then 2 because of the top and the bottom. Our lateral area, our perimeter, is just 6 sixes. 6 plus 6 plus 6 plus 6 plus 6 plus 6 times our height, which is 10. So to simplify this, I'm going to cancel out my 2's. I get 6 times 6 is 36, times 3 is 108, radical 3, oops, 108, radical 3, and then we have 6 times 6 is 36, so plus 360. So if you just take your calculator, multiply 108, radical 3, and add 360, you end up at 547.1 square units. So the biggest problem there was finding that area of that hexagon. On to number 2. Number 2, we have a triangular prism. Triangle's a little easier to find. So again, I have two bases that are both triangles. I need the base and the height for that. Again, base and height have to be perpendicular, so I need this side. Well, if I have 9, which is 3 times 3, for one of the legs, and 15, which is 5 times 3, then we know the other leg has to be 4 times 3, or 12. So for my triangle here, I'm going to do 12 times 9 divided by 2. Again, we have 2 of those, top and bottom. The lateral surfaces, remember, we're all rectangles, so we do our perimeter, which is 9 plus 12 plus 15. So those all add up to 36 times the 10, which is the height. So I'm going to simplify this. Again, my 2's will cancel. I get 12 times 9, which is 108, plus the 360. So we get a total of 468 for the surface area of this triangular pyramid. I'm sorry, triangular prism. On to number 3. Number 3, we have half of a cylinder. If you remember, a cylinder is usually 2 circular bases. Well, we only have 1 because we have a half and a half. Plus your lateral area, which is your circumference, 2 pi r, times your height. But again, we only have half of that lateral area, so I'm going to cancel out that too. In this case, we also have this rectangle on top. That's our 4th surface that they gave us a hint about. So that rectangle, of course, is just its base times its height. So for our circle, our area of a circle, again, is pi times our radius squared. Our radius is 6. The lateral surface area, we're just doing pi times our radius times our height of the cylinder, which would be 20 if it was standing up. And that rectangle was 12 times 20. So I end up with a 36 pi for my basis, a 120 pi for my curved lateral surface, and 240 for that flat rectangular surface on top. So on my calculator, I'm just going to do 156 times pi and add 240 to get my total surface area. So for this one, we end up with 730.1 square units. For number 4, we have just a square pyramid. They give us the slant height is 10, and we have a base measuring 16 by 16. So pyramids, remember, you only have one base, and since the lateral surfaces are all triangles, it was 1/2 times all their bases multiplied together times the slant height of the pyramid. So our base in this case, each side being 16, is 16 squared. Our perimeter of our base would be 4/16, or 64, and our slant height is actually given to us there as 10. So for this one, we just need to do 16 squared. Calculate this. Half of 4 is 2. 2 times 16 is 32. 32 times 10. I'm adding 320 to 256. I get 576 square units for the surface area of this square pyramid. On to number 5. 5, we have a triangular pyramid. So again, we need that one base and then half of the perimeter times the lateral slant height. So in this case, it doesn't look like it, but this is an equilateral triangle whose side is 10. So again, I'm going to drop my height. That makes this short leg 5. This would be the long leg of our right triangle, so that's 5√3. So to find the area of my triangle, I would do 10 times 5√3 divided by 2 because it's a triangle. And to that I will add 1/2 my perimeter. I'm going to have 3 10s. So 30 is the perimeter of my triangle. And our slant height, not given to us, but we can find it very easily by dropping it here in altitude. That makes this short leg 5 in our right triangle. I have a 5, a 13. We know the other leg as part of that triple is 12. So our slant height is 12. So to simplify this, I'm going to cancel my 2 with my 10. So I end up with 25√3. Half of 30 is 15. 15 times 12 puts me at 180. So I just need to multiply on my calculator 25 times √3, add the 180 to it, and we end up with 223.3 square units. To number 6. Number 6 is just a cone. Again, I have the one base, and that's just pi r squared, plus my lateral area, which we know is the circumference, well, 1/2 because it's triangular, 1/2 times the circumference, 2 pi r, times our slant height. Again, the 1/2 and the 2 cancel here, so I really just need to do pi rl. So for my circular base, I need my radius. Again, I hope you recognize a triple here in our right triangle. 8 and 10 go with 6. That's a second multiple of our 3, 4, 5. So 6 squared gives me 36 pi for the base. And then I'm just doing pi times my radius times my slant height, which was 10. So I'm basically adding 36 pi to 60 pi to give us 96 pi, which we'll have to multiply out on our calculator. And you end up with 301.6 square units. On to number 7. Number 7, they ask a question about the ratio of surface areas. Well, we have two spheres, one with a radius of 3, one with a radius of 6. So right now the radius, or the ratio of their radii are 1 to 2. We're going to look at the ratio of their surface areas. If you recall, the surface area of a sphere was just 4 pi r squared because we have 4 circles that would cover the surface of a sphere. So for our little sphere here, my radius is 3, so I'm going to get 4 times pi times 3 times 3 is 9. For my large sphere, it's going to be 4 times pi, and again my radius is 6, so 6 times 6 is 36. I could multiply this out, but I'm going to end up reducing anyway, so I'll cancel the 4s, I'll cancel the pi. 9 over 36 reduces to 1/4. Our ratio of surface areas is 1 to 4. Makes sense. If our straight line measurement ratios was 1 to 2, a two-dimensional ratio is going to be squared that, or 1/4. On to number 8. Number 8, they tell us the square pyramid has a surface area of 64. We need to find its edge, base edge, and they tell us the slant height is 6. So again, I would be finding the area of my base and adding the lateral area. The base is just side squared, side times side. The lateral area would be 1/2 times my perimeter. My perimeter is 4 s's, and my slant height was 6. Recall that is equal to, as they told us here, 64. So there's my equation. I have one variable I need to solve for s. Let's simplify. So I get s squared plus 1/2 of 4 is 2. 2 times my 6 puts me at 12s. And if you notice, this is a quadratic, so how do we solve quadratics? Let's set it equal to 0 and see if we could factor it. So I'm going to bring my 64 over. Remember, that turns to negative 64. And set that equal to 0. So it looks like we're going to have a factorable quadratic here. First terms obviously are s and s. Last terms need to multiply up to negative 64, so I've got one positive and one negative factor I'm working with. They do need to combine and give me 12s in the middle term, so I'm going to go with 16 and 4, which means the solutions to make this equal 0, s would equal negative 16, and the second solution would be positive 4. Since we're talking about the side of a square, the negative answer doesn't make sense. So our side length is 4 centimeters. Taking us to number 9. Number 9, we have a composite figure made up of a hemisphere and the outside of a cone, the lateral surface area of a cone. So our hemisphere, normally 4 pi r squared, well, we only have half of it, so we're going to change that down to 2 pi r squared. And then our lateral surface of our cone, if you recall, was pi r l. So let's fill in what we know. I have 2 pi, my radius is 6, so 6 squared plus pi times 6 times my slant height. My slant height wasn't given, but again, we have 6 and 8. We know that hypotenuse is 10, so my slant height is 10. So 36 times 2 puts me at 72 pi. 6 times 10 puts me at 60 pi. Our final answer, we just need to multiply 132 times pi to get our total surface area. 132 times pi on my calculator puts me at 414.7 square units. And for number 10, our last one, we also had a composite figure. We basically have a hemisphere here and a hemisphere here, obviously making a full hemisphere, so we have to do 4 pi r squared. And then we have the lateral area of our cylinder. So again, that was circumference, 2 pi r, times our height of our cylinder. So if we look back at our picture, it looks like 3 is our entire diameter, so our radius is going to be 1.5. So if I fill that in, I get 4 pi times 1.5 squared plus 2 pi times 1.5 and the height of my cylinder. Now it's not 11, remember, I only want the distance from here to here. Recall if your radius is 1.5 in one direction, it's 1.5 in all directions. So it's 1.5 from here to here, same thing over here. So I have to take a total of 3 off here, making my height 8. So I'm going to multiply by an 8 here. So let's simplify. 1.5 times 1.5 is 2.25. Multiply that times 4, we end up with 9 pi for the first part. And then 2 times 1.5 is 3. 3 times 8, we end up with 24 pi for the second portion. Add those together, we have 33 pi. So our total surface area of this solid ended up being 103.7 square units. And then that is it for that quiz. Thank you.